In case if any question occurs, we will be sharing it to you through the text itself, the answers. So again, thank you so much, sir, for joining. And now we would move ahead to the next session. I will just share the screen of the speaker. So yeah, the topic that I believe will have a lot of questions and answers, and that is about the battery ecosystem and the battery system. So this would be given by Mr. Rahul Bollini. Mr. Bollini has over 6 years of experience, and he is an international lithium-ion cell research and development consultant. He has closely worked with Indian, American, European, and Japanese companies with hands-on experience in lithium-ion cell engineering and the fabrication process. He has studied energy business and finance from Pennsylvania State University, USA. So without wasting the time, I believe I can owe the platform to Mr. Rahul. So yes, Mr. Rahul, I believe you can take over.
Hello, everyone. Yeah.
Yes.
So let's get started. I think people had some questions, so I can take some of the questions now. That's not a problem.
Yes.
Can you just read out the questions actually?
Sure. I mean, if you want to take the questions way ahead the presentation, it's fine, because in the interest of time, I believe we can also compile the questions and answer it in the text if you're okay with that.
Okay, so let me get started.
Yes. So you can share your screen and we can.
Okay.
Go ahead.
Yeah, what?
Mr. Rahul, are you there with us?
Yeah, just give me a minute. I'm just, opening my PPT.
Sure, sure. No worries.
Sharing one.
No worries.
Yeah, let's get started.
Yes, Mr. Rahul. Thank you so much.
Can you all see my screen?
Yes, we can see your screen.
So let's get started with the introduction to electric vehicles. So what is an electric vehicle? So it's a very hot topic these days. Everybody is wondering, what is an electric vehicle? There's a lot of, talk about it. So let's get started. What is an electric vehicle? Electric vehicles are vehicles that are powered by electrical energy. Generally, the electrical energy is provided by batteries. And when you compare EVs with ICE, which is internal combustion engines, they have lower running costs because they have less moving parts for maintenance. EVs don't have exhaust. I think someone was talking about tailpipe emission and all that. So such a thing doesn't exist. And there's no spark plugs that come in petrol cars and petrol vehicles. There's no clutch or gears. It's a single speed system. Yeah, there's no gear. EVs are environmentally friendly compared to vehicles that use petrol or diesel because there's no fuel burning inside the vehicle. EVs are more efficient and do not make noise during its operation. So if someone has seen an EV passing by, you would see that it's not making a lot of noise. Yeah. Traditional powertrains, the cars and the petrol diesel cars, they have a lot of parts in them. That's why you end up paying a lot in maintenance costs. They have as much as 2000 electromechanical parts. But when you see an EV, it's just few components, such as motor, controller, this battery, and then a few things here. Generally, we say as close to 20, which is 1% of the parts that is there in the ICE vehicles. So history of electric vehicles, let's talk a little bit about it. Yeah. So there was a priest in Hungary back in the day. This is, we are talking 1827. So out of nowhere, he just put an electric motor with stator, rotor, and commutator to his tiny car, and it actually worked. So many believe that, historians believe that that could possibly be the first electric vehicle ever made. Yeah. So early 1900s saw a trend for EVs. So there was a lot of trend for EVs, especially in the United States market. And around the same time, the founder of Porsche developed an electric car, which is a little bit kind of like a sporty model called P1 in 1902. And it all crashed down, and it faded away after in 1908 when Henry Ford launched Model T, a highly mass-produced vehicle which was less than 50% of the cost. So this normal electric vehicles with lead acid battery would be sold for as much as $1,600 to $1,800, and Model T from Ford was close to $600. So you can see it's less than half the price. And that's when EV started taking a hit and started disappearing. This is the US market we're talking about. And then electric vehicles were short-lived in 20th century. And then around 1990s, Environmental Protection Agency of US, EPA, they again started putting pressure on companies such as General Motors and all that to get into EV. And GM developed the car, and they launched the vehicle, but it was, I'll show you the photo next. You will see that it didn't last very long. It was not very appealing. So this is EV1, which was launched by General Motors, and it only had like 2 doors. Not very appealing. Maybe, because they make a lot more money in petrol cars. They wanted to, just for the sake of doing it, they developed some cars, and these were not sold in the market. They were leased in the market. So it was easy to recall them and bring them back from the roads. And on the left, you can see a charging station from 1973, where people could just charge. It looks very simple. It's all lead acid batteries. There was no lithium-ion batteries. Lithium-ion batteries were invented in 1991. So this is 1973 we are talking about. Types of electric vehicles. So it all started with HEV, which is also called as micro hybrid in India. HEV combines a conventional ICE engine, and then along with a smaller motor and a smaller battery pack. So this would typically work in a way where it will work like giving you better mileage. So whenever your vehicle is running at lower speed or something like that, the smaller motor would power the vehicle. Whenever you're going at higher speed, the petrol would take over. So it was popularly made by Toyota Prius, which was a big hit in US. But in India, it didn't take off because of price increases. So basically, you're having petrol engine and again then electric motor. The cost just builds up. And I think Camry also launched a hybrid vehicle, but it didn't take off. And plug-in is also similar to hybrid, but it has a bigger motor and a bigger battery. So plug-in, when you compare it with HEV, the difference would be that in plug-in hybrid, you have an option to switch off the ICE or switch off the hybrid engine. That is a electric vehicle motor. But in HEV, it's all controlled by the system. You have no control over when the electric motors can take over or when it cannot. And if you run out of charge in the plug-in hybrid, you can just go to a petrol pump and fill your petrol and keep running until you find a charging station or until you go home. This is the basic difference. And I'm sure you'll get the notes after the class. So this is, I've written as elaborate as possible so that tomorrow you can refer to the notes as well. But that is the general difference between HEV and PHEV. Yeah, both are hybrid vehicles, but one is the plug-in. So it comes with a charger. Hybrid vehicles, HEV doesn't come with a charger. Now let's move on to BEV. And BEV is what we are talking about. A general electric vehicle is called as BEV because it's battery-powered electric vehicle. There's no petrol or diesel. There's no ICE, nothing at all. So you can see in India, there's Tata Nexon, which is selling like a hot cake in India, especially since the last 1.5 years. And Tata Tigor is also kind of taking off because it has a license to be commercialized. You can use it for taxi fleet, while on the other hand, Tata Nexon doesn't have a license to run under a taxi fleet. I'm seeing a lot of Tata Tigors and Mahindra E-Veritos as taxis. Yeah. So it's a simple system where batteries power the electric motor. Generally, if you see cars, you see AC synchronous motor, and when you see two-wheelers, it's generally BLDC motors here. And the upcoming technology, where I'm sure you people might have heard about this hydrogen and all that. So that is generally called as FCEV, fuel cell electric vehicle. FCVs are similar to BEV, but the energy is coming from hydrogen gas rather than batteries. So how it works is basically FCEVs create their own electric charge through a chemical reaction involving hydrogen. And why there is so much push for hydrogen is because you don't need to charge a battery, where battery charging takes anywhere between 30 minutes to 2 hours. Hydrogen filling doesn't take that long. It could be a couple of minutes. Yeah, but hydrogen has its own challenge, especially in a country like India, where logistics can be challenging. And so there are again companies working on it so that hydrogen can be produced at the gas station itself. So how hydrogen is generally produced is it's electrolysis of water. You put electricity on water and you split the hydrogen and oxygen, um, and then you store all the hydrogen in tanks, and then you either transport it to another station, or if you are generating at the source, you can directly use it. So that is how it is. But there is cost implications. There's a lot of electricity that is used for splitting water. There's a lot of challenge, but it is coming, people. If you think that batteries are going to be forever, then you're kind of like, yeah, you need to know that hydrogen is coming. There are already Japanese, Toyota is hardly working on it, like working a lot on it. So it's coming. Yeah. This is the basic architecture of a HEV, PHEV, and the BEV. If you see, BEV is the least complicated. PHEV batteries are bigger, and electric motor is also sized with higher kilowatt. And there's a charging capability in PHEV compared to HEV. Let's go to types of batteries in an electric vehicle. So let's talk about topic two. Before 1991, when lithium-ion batteries were not invented, it was all lead-acid batteries. Even today, it's not something that lead-acid batteries are going to disappear completely. It's going to be there, but the applications that it is used for it's completely different. It's a cost-friendly application. So it is high-powered. You don't need any BMS to protect, and also very simple architecture how you use it. The main thing is it's inexpensive, it's cheap, it's safe and reliable. They don't catch fires that easily because they can take high currents and discharge high currents up to some extent. And challenges are it doesn't perform very good in cold weather, and it is something, yeah, people are moving away, especially in electric vehicles. So earlier it was there before 1991. So now the hot topic is lithium-ion batteries. And in between, people were using nickel metal hydride, generally, which is called as NMH. If you have rechargeable batteries at home that you use for, like a Duracell or something like that, or Energizer cells that you use in rechargeable cells in TV remotes, where you can charge it, you're probably using the NIMH battery. Yeah. So when hybrid was launched, Toyota Prius, they would use NIMH, and slowly everybody has shifted to lithium-ion battery. And a complete BEV uses lithium-ion battery. It's the most common type of battery used in electric cars. It's the most portable because its energy density is the highest. So it is lower in weight. It consumes less space. So you can fit in a lot of batteries of it and expect a good range in electric vehicle. It has a high power to weight ratio, high energy efficiency, good high temperature performance. It can operate as much as 60 degrees, not a problem. It has a high self-discharge rate, better than batteries, and it has a good self-discharge rate. So if you see that if you have a bike or a car and you don't use it for 6 months or a year, you'd see that the battery would have completely discharged. But that's not the case in lithium-ion batteries. It has a self-discharge rate of less than 5%. So if you're gone for about 6 months and you come back, you'll probably see that the vehicle would start. It will not be completely discharged. And recyclable, it is recyclable, although it's not being recycled completely in India, but there are a lot of government policies coming and few companies are starting to look at the recycling thing. Let's talk about nickel metal hydride. Yeah, so it's more, it was used in hybrid vehicles. They have good life, but as people would know that nickel is highly poisonous as lead. So there were concerns from the government and a lot of environmental agencies, and then slowly, it had to be discontinued as much as possible. But biggest issue is cost. It's expensive, and they cannot hold charge for too long. So the same problem that you face in lead acid batteries. So if you leave a car or a scooter for too long and you come back, it probably would have discharged. And ultra capacitors is something that companies are working on right now. It's not being used in electric vehicles, but that is also something people are working on. Like there's a company called ultra capacitor. It's more like super capacitors. Ultra capacitors is the basic version, and then you might have heard about super capacitors. If you had heard about the company called Maxell, which Tesla procured last year. So they make super capacitors. The advantage of super capacitors over lithium-ion batteries is that fast charging. You can charge ridiculously fast, maybe in minutes, 0 to 100, not a problem. And then they have very high cycle life, almost like I would say it has a life. If you count per cycle per day, it can actually outweigh a life of a human. It just lasts forever. But the challenges in that is it's very heavy and expensive, very expensive, as much as $1,200 per kWh. And on the other hand, lithium-ion batteries cost less than $150 at cell level. And another disadvantage of ultra capacitors is they cannot hold charge for too long. The super capacitors, they cannot hold for too long. So on the same day you charge, discharge is not a problem. But then again, like I told, like lead acid battery and nickel metal hydride battery, if you're gone for too long and you come back, it would have probably discharged. So that is the disadvantage. And another disadvantage is the voltage drop is very high. It's not very constant like lithium batteries or lead acid battery. So designing a BMS for it becomes challenging. So I work with few BMS companies as well, and we generally discuss that okay, super capacitors can come in the market, but designing BMS is going to be really challenging because the voltage just drops. Let's talk about lithium-ion battery in general. Yeah, a lithium-ion battery is a secondary. Secondary basically means rechargeable battery. Primary means non-rechargeable battery, where lithium ions move from cathode to anode. So when you charge a battery, it will move from cathode to anode through electrolyte medium, and when you discharge it, it will move from anode to cathode. So that's the the principle of this battery. It's the lithium ions that move. That's why many people call it lithium battery as well, but I suggest people that it's called as lithium ion battery. It's not just lithium battery because it's the ions doing the job, the functionality. So it's called as lithium ion battery. Lithium ion batteries use an intercalated lithium compound as a material at the positive electrode, which is cathode, and typically graphite at a negative electrode. It's generally artificial graphite. Lithium ion batteries have high energy density, no memory effect, and low self discharge. No memory effect is true for NMC batteries, but not really for LFP. We will talk about it again in the next slides. So these are all the types of lithium-ion cells, cell chemistry. I'm sure you people who know about lithium-ion batteries would have heard about NCA and LFP, which is third and fourth. But many of you would not know that there are so many chemistries. Some of them are in the market, some of them have disappeared, some of them are being worked on. So these are all the chemistries. So let's talk about popular chemistries, NMC and LFP. NMC is expensive, but it weighs less, it occupies less volume. So that's why it's being popularly used in two-wheeler and electric cars, where the range expectancy of the end user is high. Suppose let's take an example. There are two companies selling EV scooters. So one of them is giving a range of probably 40 and another is giving 70 kilometers. So, range is everything. If you give higher range, it's going to sell better. So NMC is popular in scooter as well as car. In LFP, it occupies more space. It's more it weighs more, but it has its own advantage. It's cheaper than NMC, and it is safer. It doesn't catch fire. NMC has a tendency to catch fire when when it's operating at about 80 degrees Celsius. And another thing is LFP lasts longer. LFP has a cycle life of anywhere 1500 cycles or above. NMC, on the other hand, has a cycle life of anywhere between 500 to 1000 cycles. Let's talk about general cell chemistry, what's also there. LCO is probably what you would see in your cell phone. It's still being used. This was a chemistry which was invented in 1991 and commercialized by Sony, and then slowly passed on to Sanyo, then passed on to Panasonic. And then slowly it entered China, and the world could see it. NMC, again, we spoke about it. And then NCA is something that is being used by Tesla. And if people know about the news in 2018 where ISRO was talking about giving cell technology to the companies in India, NCA was a technology. I was there in the meet. Yeah. So LFP, again, we spoke about it. LMO is something, it was the cheapest of all, but it had some stability issues. It was being used by Nissan, highly promoted by Nissan, but it failed. So LMO is something which has disappeared. LNO is something invented by SAFT, France, which is acquired by Total Energies right now. It didn't really take off. It's there, but it didn't really take off. And then LNMO is something, it's a higher voltage cathode. This is also industry is going to see this. It's basically NMC variant without cobalt. And cobalt is the most expensive of all the metals that you see: lithium, manganese, and then there is nickel, and there's aluminum, and then cobalt. So cobalt is the most expensive. So LNMO is something without cobalt. And then LMFP is basically LFP version, but with the infusion of manganese, which would take the cell voltage higher, and from 3.2 to all the way to 3.9. Understanding various types of C ratings. So if someone has got their hands on cells and a data sheet or something like that, people would see that there's mention of C ratings. The cell is rated at 0.2 C and all that. So let's talk about it a little bit more. Lithium-ion cells come with various standard charge and standard discharge conditions. It is advisable to use this parameters recommended by the manufacturer as close as possible, if not the exact. For example, let's take a popular cell which is being imported from China in India. It's very popular in two-wheeler, electric two-wheeler scooters. So 2600 mAh NMC cell in 18650 form factor, and most of the time it has a standard rating of 0.2 C, standard discharge rating. So it actually means that it must discharge continuously around 520 milliamps per cell to achieve a maximum cycle life and to maintain a healthy functioning. So that is the thing. But of course, two-wheelers need higher C rating. So then you're supposed to take a cell with 0.5 C rating, where you could discharge 1300 mAh per cell. And the battery would discharge in 2 hours. 0.2 C rate means the battery has to discharge in 5 hours. So that is a standard recommendation by the manufacturer. So this is something where people make a slight mistake. I'm going to write an article about this as well. Maybe it's being published in the December edition of EV Reporter. You people can read about it. Yeah. So one must also understand that discharging at higher rates can deliver lower energy. Suppose, like I said, this cell is 2600 mAh rated at 0.2 C rating. If you're discharging at 0.5 C rating, you'll probably get 95% of 2600 mAh. And if you're discharging at 1 C rating, you'll probably get anywhere from 90 to 92%. So the cell is technically not going to give you 2600 mAh of energy. So this is, again, people have to keep in mind. So design the battery voltage as per application. So if you people are looking into battery packs, so I'll give you a little bit more example, because cells nobody's making in India, it's all imported, mostly from China and then Korea, Japan. Let's talk about battery pack, which is the most popular. Yeah, there are hundreds of company in India. Yeah, it is always recommended to size the battery voltage higher than the voltage required for the application. This allows for drawing lesser current. It helps when the battery is operating at lower SOC. So you people might see that when the scooter, typically in a scooter, when the SOC, which is the state of charge, suppose the battery percentage of the scooter is on the lower, you will see the vehicle will not move very fast as compared to when it was, at 80% charge or something like that. So that is the voltage has dropped, and you cannot expect a lot of amps from the battery. So that's why I suggest companies to use a higher voltage battery, so that the stability is still there when you're at higher, lower SOC. And it applies mostly to NMC. Scooter uses NMC, obviously, where the discharge curve is not so flat. LFP has a flat discharge curve, so it doesn't matter. Some NMC cells claim to have 3.7 volt nominal voltage. This is mostly cells coming from China. You'll see the data sheet says 3.7 volt nominal voltage. And one must know that as you're charging and discharging the cells over hundreds of cycles, the nominal voltage kind of shifts down and eventually settles anywhere close to 3.6 volt. And that is the reason why famous brands such as LG, Samsung, and Panasonic advertise the cells with 3.6 volt nominal voltage. And technically, the cells have a nominal voltage of 3.63 to 3.66. So Chinese tend to call it as 3.7, rounding it off on the upper side, But good brands like LG, Samsung, Panasonic, they try to take a safer calculation and call it a 3.6 volt nominal voltage. You look at the graph and make your own calculation, average value, you would see that it comes closer to 3.6 and not 3.7. And why I'm talking about this is this becomes a major challenge when you're making a 48-volt battery pack using NMC. So most companies in India I've seen they use 13S, that is 13 series, thinking that each cell is 3.7 volt. It would be 48.1. But on the other hand, is actually closer to 3.6. And when you multiply 3.6 with 13, you would see that it comes down, it comes maybe 46.8 or something like that. That's why I suggest companies to go with 14S rather than 13S. And similar things happen when people are making battery packs for 60 volt application. People take 3.7 into 16S, comes to 59.2. I suggest companies to take 3.6 into 17. These are some common, suggestions I give to the company because see, I come from cell background, so I know exactly how cells are going to behave, what kind of safety aspects can come tomorrow, and how you're degrading the life of the complete battery pack just because you wanted to skip a row of cells. Yeah. So let's talk about lithium-ion battery pack process. So whenever you get the cells, obviously it's imported. You put them in a cells formation and grading. So the formation process is basically a cells come anywhere 30 to 50% charge when it's coming from the manufacturer. You're supposed to full charge it and then full discharge it. So when you're full discharging it, you will know the actual capacity of the cell. Because anywhere you about the cell capacity, it means the discharge capacity, not the charge capacity. The amount of energy it can deliver at discharge. And then what happens is you have to again charge it back to 50%. Now, next point I will come to why charge it all the way to 50%. Because you are going to calculate the OCV, open circuit voltage of each of the cell, and IR, which is done in a cell sorting machine. You can see on the right side, you see a machine with 11 channels. So based on the value input, it's going to give you all the cells in different channels. So all the cells coming in a single channel, they have to be used in a single battery pack. And next, when you're proceeding further, you're supposed to use a cell cell spot welding machine. This is a manual machine. Obviously, there is a two-side automatic machine as well. So you're going to put the cells on top of a cell holder and put the nickel tab, and then you take it all the way to the welding machine where you weld it in series and panel combination. And the nickel strips thickness vary based on the current that you draw. It's generally 0.15 mm for a two-wheeler application. And further, when you receive a BMS from a manufacturer or you're developing your own, you're supposed to run it through this BMS tester, where it shows if it's okay, if it's going to do job, functionality, and all for over 30 parameters, to be 35 to be exact. And then only after that you would attach the BMS. You can see on the right the complete organization of a battery pack, how it's done, the cell holders, nickel tab welding and cells. They go in a metal box, and the BMS being integrated. So before going to the metal box, the batteries are put in a battery pack aging machine where you charge it all the way and then discharge to see how the capacity, discharge capacity is when all the cells are together as a battery pack. And then again, you charge it up all the way based on your customers, your clients, what SOC they want. Some companies ask for 50, some ask for 70, 80. Some companies also ask for 100%, which is actually illegal. Government norm says during transportation, you're not supposed to send something fully charged. So okay. Let's move on to battery recycling. So battery recycling is something people are talking about. And because lead acid battery can be recycled over 95% of its component, in lithium-ion battery there is scope, but people want to know how it's done, and people are excited and curious, I would say, to get into this. So let's try to analyze this cycle. So raw materials come and it's being supplied to a manufacturer who makes us cell, and then it's used in applications such as cell phone and all that. And after being used, the batteries come back to a collection center, and then again it goes to the cells are dismantled from application and then sent to reuse or refurbish. So center where it would be seen that okay, the cells have good voltage and good capacity. Okay, you can reuse it again in something applications with low power, where the discharge the discharge power is going to be low and the charging speed is going to be low, something like solar. And if the cells are unfit, then you would put them to a recycling center. So let's talk a little bit more about recycling. So when the cells go to recycling center, um, the it is basically crushed, put in a crusher, and then some metals such as aluminum, copper, and all that they are separated, and then you see a black mass, which mostly consists of the cathode material, and it actually has lithium, manganese, cobalt, and nickel. This I'm talking about LMC cells, and this black mass is again sent to a refining um, company, which would refine it in a way like how petroleum is refined, where in multiple channels you get the multiple outputs. So something like that, at different higher temperatures you can extract cobalt, nickel, etc. And again, when you extract the cobalt, nickel, and everything, you would send it back to the salt manufacturer, who would make cobalt sulfate, cobalt tetroxide, and nickel sulfate, and send it back to a cathode manufacturer, who would integrate it with lithium, um, lithium hydroxide, and everything, and then send it back to cell manufacturers. That's the process. Second life batteries. So I was just talking about how this is a graph given by McKinsey and Company. So basically, you manufacture the battery and you put it in an EV, and then once it's coming back, it's a used battery pack. You have two options. One is to reuse it, or you send it to recycling company. So that's what is explained in this chart. This is Chevrolet Volt, which was very popular in US back in the day. This hybrid car, by the way. Yeah. So it's a PHEV. So it did some good sales back in the day. So just to showcase that batteries can be reused, Chevrolet came up with this idea that let's take some batteries and make a ESS application. So this is on top, you see the car, bottom you see the pack architecture, how it's integrated, and on the right you see the complete, the way it's made. The Chevrolet Volt. So this is basically reuse, second life batteries. Let's talk about battery management system. What is a BMS? BMS is full form is battery management system. It manages a battery pack by protecting the battery and making sure that the battery is operating in its safe operating zone. And some of the things it does is monitoring its state, controlling its environment, and balancing the cells inside the battery pack. And additionally, it can calculate data and report data via various communication protocols such as CAN 2.0, UART, Bluetooth, etc. Types of BMS. There's hardware BMS. On the left, you see hardware BMS, which does a basic job of protecting the battery pack. And you can see a cable coming out, red and black cable, and that is on the end. You see one black color bulb kind of thing. That is a thermistor, which would sense the temperature of the pack, and if it reaches about 65 degrees, it will just cut off the battery. And once it comes down to 60 degrees, it will come into recovery, and you can actually, the battery works. So if at all you come to a situation where the scooter has shut down suddenly, so you don't need to panic. It's just BMS doing its job, because batteries used in scooters is NMC, and they're not supposed to hit 80 degrees Celsius. At 65 degrees, maybe you're in a hot place, or you have been driving too fast, or you have been driving overload, or maybe you're driving uphill for various reasons. If it has touched 65 degrees, this thermistor will cut off the battery. No need to panic. It will just take a few minutes. Battery would come down to 60 degrees, and then your vehicle should start working fine. So that's a hardware BMS, performs basic protection functions to keep the battery pack functioning as healthy as possible. And then there is a smart BMS, which is also called a software BMS. It has all the features of the hardware BMS, and additionally, it can collect data. So there'll be a memory inside, memory card, which can store the data, and then it can support GPS tracking, so that so this is especially for the battery swapping station companies. They would like to know where their batteries are, and if it has crossed a particular geography, or for theft reasons and all that. And then the protocols that it could use is Bluetooth, CAN, UART, etc. to send the data. Obviously, there's cloud also, so live online tracking can be done. Functions of a BMS. These are the functions. Enforce a lower cutoff voltage. If the cell if the cell is reaching a particular voltage, the energy has been drained out, and simply it's just going to go at a lower voltage, and it damages the cell. So it would enforce a lower cutoff voltage so that the batteries don't discharge anything lower than that, and upper cutoff voltage. So this is the main feature which directly relates to safety. Cells should not be overcharged. Let's take example of MNC cells. The upper cutoff is 4.2 volt to 4.25 volt. If you're trying to charge above that voltage, batteries are going to catch, definitely going to catch. So BMS restricts the voltage, upper cutoff voltage, and then control the current coming in during charge and discharge. So this is basically the continuous current, peak current during charge and discharge. So you can set it in the BMS. Then temperature control, as I was telling, there's a thermistor involved. So it can, smart BMS can look into individual cells as well. And the battery pack, if it's going above certain degrees Celsius, it's going to cut off to make sure the cells don't go any higher temperature and then get into thermal runaway. And thermal runaway is basically catching fire. It's a nice fancy term we use in the industry to replace the word fire. Yeah. The state of charge, SOC, can indicate, suppose you take your cell phone, you see it says 68% charge. So that is the SOC, state of charge. Depth of discharge, how much energy you're draining out, the percentage of energy that's available in the battery and the percentage that you're draining out of the battery discharging. That's called depth of discharge. So BMS can look into that factor. It can actually record the data. State of health. So state of health is something, when you buy a new battery, the state of health is going to be 100. And as you keep using it, you will see the retention capacity of the battery has come down because some of the lithium ions don't come back. Like I said, how lithium ion cell works. During charge, it goes from cathode to anode, and during discharge, it comes back from anode to cathode. So as due to aging, some of the lithium ion stay back. In anode, they don't come back. So that's why the capacity fades. And SOH will tell you. If any of you have an iPhone, you can see, go to the battery section and see battery health. There you can see that battery is 86% or something like that. And the minute it hits 80%, you'll get an alert from the general Apple itself that it's highly recommended that you go and change your battery. That is SOH. State of power. It indicates the time of power available based on your existing usage. This is not really for power in two-wheeler because the power varies, the speed varies, there's a lot of road variation and all that. This is more for ESS applications. Suppose you're running some loads, it can tell you that in this existing loads, how much hours of backup you have, or something like that, simple as a power bank as well. And then energy delivered since last charge. These are all data that a smart BMS can collect and store in the memory card, and later, send it through a CAN communication or RS485. Internal resistance of a cell to know the open circuit voltage, number of charge discharge cycles, total energy delivered since first use, total operating time since first use. These are the functions of a BMS. Useful parameters in BMS. So this is particularly relating to companies who are already working on battery packs. So I wanted to share about it. If you observe the discharge graph in an NMC cell, there's not much energy left in the cell after it drops below 3 volts. So I highly recommend that the lower cutoff be 3 volts, but many companies I see, they take it all the way to 2.7, some all the way to 2.5 as well. The energy that you achieve is much negligible. Almost you can ignore that. So I highly recommend that you cut off at 2.9 volt. Take a BMS which cuts off at 2.9 volt, and with tolerance it comes down to something like 3 volts. Similarly, there's no energy in 2.7 below 2.7 volt in NMC. It's highly recommended to cut off as close as to 2.7. Generally, I recommend 2.8, 2.9 is also okay because it has a flat discharge current. Avoid charging the cells to the upper voltage, which is 4.2 in NMC and 3.6 volt in LFP. It can severely impact the cycle life of the cells. If you see a cell phone being charged maybe at 96, 97 or 98%, you'll see it charges very slow and it generates a lot of heat. And heat is the biggest enemy of a battery. Generally, heat is a problem. So I highly recommend that you don't go all the way to 4.2 volts, maybe cut off at 4.15, 4.17, that's okay. Similarly for LFP, I say maybe 3.55, that's okay. So you will save some time that it takes to charge at the end. And then the heat that the battery has to see, heat being generated, that is reduced. And this would actually extend the life of the cells. If you see the last slide, it talks about, I can't see it my side. Yeah. Did you know that if the cells are being charged a full charge at 4.1 volt rather than 4.2 volt, the cycle life is almost double. Because like I told before, you're not going all the way up. The heat generation is not going to be that much, and it actually doubles the cycle life. But obviously the energy that it's storing would also be less. It would be as close as maybe 90%, something like that. OEM should use controllers that cut off the battery before the BMS does when approaching low voltage. So suppose let's talk about scooters, 48-volt scooters. Mm, A good controller will cut off the battery somewhere 42 volts. That's a good thing. And the BMS cutoff should be below the controller. And this I'm telling this because sometimes controllers fail. Controllers are very notorious in the market to fail for various reasons. So if the controller fails, the motor will be drawing current, and then BMS has to do the job of the controller, which is cut off, lower cut off. This is a quote I tell in the end. Generally, batteries are classified as dangerous goods. Please handle it with the right science. So I've pretty much talked about the science involved. In Q&As, we can discuss.
Well, thank you so much, Mr. Rahul, for that wonderful, insightful presentation. It was really informative to such an extent that I believe a lot of questions in the audience who had about lithium-ion batteries, the life of batteries will be answered. Yet, I think we can take around 10-15 minutes if you are available to have.
Yeah, no problem. I'm available. Actually, during the last discussion, I had to go, but yeah, today I'm
Yes,
ready to take as much as possible.
Great.
I'll make
So,
sure I clear all the
well, to be
questions.
honest, even I had some queries of my own, which I believe
Sure.
after listening to your presentation, I guess it's solved.
Sure.
But
Just
I
shoot.
would
Yeah.
I would first ask the question about the life of battery. What type of battery is used for EV, and what is a tentative life of a battery? So that's like your first question.
Okay. So let's talk about scooters.
Mhm.
If you look at, again, it depends completely on the brands. Let's talk about popular ones like Ather, Ola, and which is TVS. They all use LG cells. LG cell is my favorite. I come from cell background. I can literally tell you LG is my favorite. So they have a life of about more than 1,000 cycles, obviously, anywhere around 1,200 cycles, all the way to 1,500 cycles. Again, it depends, how the batteries are done. Like I told you, if people try to do 13S, it's going to be a problem. If people try to charge all the way to 100%, it's going to be a problem.
Okay.
So yeah, so if you're doing it in a nice way and playing it safe, it can go all the way to 1,500 cycles, not a problem.
Okay.
So 1,500 cycles of at 80% depth of discharge. So suppose TVS says we are going to give you a range of 95 or 100. 80% depth of discharge is you're not going to discharge the battery all the way to zero. You go somewhere like a cell phone. It comes down to 20. You go back to charging.
Charging. Okay.
Yeah. So if you're using 80 kilometers out of 100 and use it, so you can achieve easily into 1,500. Not a problem. You can go all the way to 1.2 lakhs.
Okay.
But if you're doing deep discharge, the cells will start swelling. Cells will start leaking. A lot of issues are there.
Okay. That was I think enough for that, I guess. Next, I guess one question from Mr. Sakar: how does the electric charging stations get the power from? So it's about the power that is used to charge an electric vehicle.
From the grid.
Yeah, from the grid. So it is basically whatever the grid be, maybe renewable or not renewable, it is coming from the grid, is it?
It's mostly non-renewable.
Okay.
So I always tell people in all the webinars, see, electric vehicles are only green if the energy used is green. Or else, you're burning some coal somewhere and transporting with losses. With step up transformer, step down, and all the way, and then charging your vehicle. Or it's better to do the petrol burning, in cities.
Yeah.
It's going to be the same. But only thing is, out far away, coal is being burnt. It's not going to pollute your city.
Yes.
It's going to pollute some others town.
Yes.
It's the same thing. So government is working on a lot of solar adoption, but it's going to take a while. I think parallelly it's supposed to work. So we can complain, but we can see some improvements in future.
So we can hope for the day where we will at least have some distribution of renewable energy into our batteries.
So that is why government is also highly, promoting, solar rooftop at homes. So if you have a scooter or a car or something, you can have a solar rooftop as well at home.
Wonderful.
And generate the equivalent kind of energy so that you can feel green, if not someone else or the government.
That's really good. And also you had mentioned about tailpipe, and at least like though we are using some renewable energy, at least we are doing good to the environment by not producing that instant tailpipe emissions. So that's one good thing about driving an EV, I assume. So I guess next question is again about the range, which you have answered from Ankita Gupta. And Suresh Wagmare, again, he has asked about the life of a battery, where This is an interesting question. It is relevant to the sustainability industry. So, Mr. Romka has asked, lithium is very important to make batteries. So, do the world have enough lithium to make EVs? And also following that, he has asked, like many minerals are like, used. So, although if this is the case, then what will be the scenario for the sustainability? Like, is sustainable mining used, or is recycling done in this EV industry? So, any lights on that, Mr. Rahul?
Sure, sure. So the metals that is being used, obviously lithium is
Yeah.
limited. We don't have anything in India.
Okay.
People claim there is some reserve in Karnataka, but there's a difference between resource and reserve.
Okay.
Resource is something that's profitably exploitable. Reserve cannot be, so it's not going to meet the market standards, obviously. So let's not talk about that. So today,
Okay.
a lot of lithium is coming.
Mhm.
Most mining of the ore is done in Australia.
Mm-hmm.
And then there's a lot of reserves in Chile, Argentina, Bolivia. We call it the ABC Golden Triangle, or many names actually.
Mm-hmm.
Yeah. So there's a lot of it actually. You don't
Okay.
need to have to worry, and that does not mean that they will not end. Obviously, it has to end one day. So
Mhm.
more focus is being given on the recycling, so
Okay.
that most of them can be reused with minimal wastage. So
Okay.
as of now, it's okay, and that's why people are trying to get into sodium-ion batteries, at least for storage. So I
Okay.
think someone is talking about, is lithium-ion battery better than sodium-ion?
Yeah, exactly.
Sodium-ion batteries have a higher life,
Okay.
but if you look at a periodic table,
Mm-hmm.
lithium comes above sodium.
Okay. Mm-hmm.
Yeah, exactly above. And above lithium comes hydrogen. So the
Okay.
ultimate target is moving towards hydrogen, not towards
Hydrogen.
sodium. So it
Okay.
doesn't make sense. So it's just
Yeah.
a market talk. People just talk about it, but
Mhm.
technically it doesn't make sense. And
Okay.
what is a sodium ion battery? It is going to be NaNMC rather than LiNMC. It is still going to use nickel, manganese, copper. You're
Yeah.
just using a higher, a
Uh-huh.
bigger molecule instead of lithium, and
Lithium.
making so the
More
energy density is
complex.
going to be ridiculous. Yeah.
Yes,
And people
exactly.
start telling, oh, sodium is abundantly available, cheap. And I
Uh-huh.
ask them, how by cheaper by how much? We
Okay.
hardly use 4% of lithium metal in a
Mm.
cell. So how much are you going to? Maybe sodium is 90% cheaper. That's going to have an impact of, maybe 3.5%. But
Okay.
look at the mass production, 150 gigawatt hour of lithium ion battery being produced across the
Mm.
world.
Yeah.
Sodium ion starts with half a gigawatt. It's going to see economies of scale also matter. So
Okay.
I personally feel, it's just
Mhm.
people talking about sodium ion, but that does not mean people should not move towards it. Obviously, it's
Mhm.
something for storage, energy storage, not for reuse.
Okay.
Yeah.
Well, I guess that's enough for that question, I
Mhm.
believe. Thank you for
Okay.
that answer. There is another question about a two-wheeler burning. I mean, is
Yeah,
the
yeah. That's that people are talking about it a
you
lot.
can address
In fact,
that
there were
also.
two. So
Okay.
I think Mr. Ganesh Prasad, you're talking
Yeah.
about EV being burnt in Hyderabad,
Yeah.
correct? I'm assuming. So I don't want to tell the company name for obvious reasons, but yes, it is
Yeah.
going to be a common sight in future, for the
Mm.
simple reason that the way batteries are packed, the
Mm-hmm.
way the BMS is being set for the lower deep discharge and upper
Mm-hmm.
cutoff voltage, people want the maximum energy out of a cell, so they go
Mm-hmm.
with lower cutoff, much lower cutoff voltage, and 4.2, people want to go all the way to 4.25. And the depth of discharge, what I was telling if you can get 100 kilometers, does not mean you will discharge the battery all the way till 100 and only then charge.
Mm-hmm.
Sometimes it's the manufacturer's battery design, and sometimes it's the driver. All
Mm-hmm.
of them, they are contributing. And the major issue I tell is, generally batteries are heating up,
Mm-hmm.
and the fire happens when the cells see the day of 80 degrees Celsius. So
Okay.
the BMS, the thermistor would have failed,
Mm-hmm.
and the batteries kept getting hotter, and they reached 80 degrees Celsius and it caught fire. That is the only explanation I have. It could be
Okay.
bad design, bad cells,
Mm-hmm.
or bad BMS, many things. But
Mm-hmm.
whole idea is it has reached 80 degrees Celsius. There was no control. See, this
Mm-hmm.
kind of scooters, they are sold at about 80,000 rupees. You cannot put liquid cooler.
Okay.
Yeah.
So
So that is
thank you
that's yeah.
for that answer, I guess. Well, in the interest of time, Mr. Rahul, I believe we have to move on. There are some
Mhm.
other questions from the audience, which I believe if it will be great if you could answer by text in the chat box. So please, can you answer the questions from Mr. Sagar and Mr.
Just
Mithun
hold on.
and Javaji?
One,
Okay.
1 minute. Hmm. I can't see the chat. Okay, so
Yeah, yeah.
I'll just try to finish it because I have another webinar at 4 I have to leave.
Okay.
So yeah,
Okay.
I'll just keep
Oh,
it quick. So
quick it,
what was the
yeah,
next question?
quickly you
Yeah,
can tell. So
yeah,
it
yeah.
was
What is
about the hydrogen dioxide fuel cell, about what is the byproduct, what is the discharge rate of that fuel cell, and is there any byproduct?
it's all lab level. Lab level, you'll see lithium sulfur,
Okay.
lithium air, aluminum air. So many batteries
Yeah.
are there. It's
Okay.
not commercially available. I don't believe lab data, to be frank.
Oh,
It
okay.
has to be reaching technology readiness level of 9 and come to the market.
Mm-hmm.
Only then I talk about it.
Okay,
Lab
great.
level, thousands of paper are being written. So I
Great.
generally don't, I try to stay away from all that. Yeah.
Great.
So
Great.
fuel cell, yes, it's coming.
Mm-hmm.
H2O2 is talking about generally, the,
Mm-hmm.
okay, discharge of fuel cell. So
Yes.
fuel cell basically it works on PEM, proton
Mm-hmm.
exchange membrane.
Mm-hmm.
So where the reaction happens and the hydrogen is taken and electron is taken out of hydrogen, and then it is
Mm-hmm.
supplied. And the motor would be almost similar. Only
Mm-hmm.
the process is electron is going this way. In lithium-ion cells, electron move from the anode.
Uh-huh.
Yeah. So but it's all about removing the electrons. It's always about the electrons. Electrons are the energy. So it's
Mm-hmm.
something similar to that. Yeah. So what is the next
So
question?
the next question is fast charging or slow charging better, considering we have an
Slow charging any day. Slow charging.
Okay,
Fast
that's fine.
charging, you might have seen, OnePlus phones and all that. They give you fast charging, but if you see in a matter of 1 to 1.5 years, which is typically around 500 cycles, the batteries degrade so much. The battery holding capacity gets very, very bad compared to MI phone, which does slow charging. Even I use one of the fast charging phones, which charges 0 to 128 minutes. So it's
Mm-hmm.
been 14 months, my battery holding capacity is gone. So that's the price you have to pay. I know it's going to cost me 1,500, 2,000. I have to do it, but it has given me convenience. So it's
Okay.
not always about getting all the things you get. As you can save time, then you have to pay the price for it.
Mm-hmm.
So any day slow charging is better.
Okay. So final question, I will like love these two questions. I mean that there is a reference from the Back to the Future movie where flux capacitor is used, which uses plutonium. So that mineral plutonium, can it be used in this EV sector in the future?
See, not
Is
in batteries.
okay.
Plutonium is basically radioactive.
Yeah.
So where you have to break it down and
Mm.
and if
It's
anybody see, I am an energy engineer, so I know about all the energies.
lethal.
So
Yeah.
I studied about nuclear as well. So
Mm.
the major issue is storing the
Mm.
radioactive waste, the
Mm-hmm.
byproduct. Second thing is the
Mm-hmm.
reactions happen at such high temperatures.
Mm-hmm.
There's one of the reason why India is not moving towards nuclear plants. It's
Okay.
it's a very complicated science. That is something you cannot expect in a small car. Is what I'm trying to tell. It's a very
Okay.
complex process. You have to pour in a lot of water. Now I'm assuming you're not going to be pouring a lot of water, inside a car.
Mm.
Liquid cooling is different, but if you have actually seen a nuclear plant, you'll see a lot of water is being poured.
Okay.
That's not going to happen. Yeah. Can we use
Great.
steam energy to run cars just like trains? Yes. So what is steam doing actually? I can ask the same person. Steam is just rotating the turbine. So
Mm-hmm.
it's always about rotating the turbine. And
Mm-hmm.
generator also, when you have a hydropower, you're just moving water across the turbine so that energy is being done. Yeah.
Mm-hmm.
So steam energy is it's very, how do you get steam by burning water or coal?
Mm-hmm.
So that takes up a lot of space. Rather, I would go with batteries.
Yes.
Store energy. Yeah.
So anyways, I guess we have another technical session, I guess,
Sure, sure.
guys. So please keep the questions rolling. Don't worry that your questions will be answered by the following
And I think Mr.
speakers.
Sagar, last question, I'll just take it. He's saying,
Yeah,
what is biofuel cell?
yes.
So that is something, like I told, thousands of papers are coming in. I
Mm-hmm.
don't pay heed to all of them. If it comes to a serious technology readiness level, I would know. But I'm assuming it's a fuel cell using a different kind of fuel rather than hydrogen, because hydrogen is not so bio.
Mm-hmm.
Yeah. So, and then there's biodiesel as well, which our transport minister was highly promoting. But I have worked on biodiesel at some
Mm-hmm.
point, and I've realized that it's a negative net. The net energy is negative. It takes
Mm-hmm.
more energy to manufacture it than the energy that it gives you tomorrow when it burns. So ethically, environmentally speaking, it's not the right thing. Maybe it's cheaper than petrol diesel. Yeah,
Okay.
but energy wise, ethically, it's not the right thing to do. So that's why biodiesels were
Well,
never adopted by the Europe and all that. India, they are looking at
mm-hmm.
cost implications and for not so dependent on all these
Mm-hmm.
Middle East countries and all. For those reasons, it's being promoted.
Mm-hmm.
But yeah, it's something again debated.
Mm-hmm.
Okay.
Thank you. Thank you for that
Sure,
wonderful
sure, sure.
rapid fire session of question and answers. Wonderful presentation, Mr. Rahul.
Okay.
Please shed this light of awareness to all the other people. Thank you for your wonderful session. I believe we can like move ahead with the next session. Have a